Greetings, my name is Neil Peterson, and I'm the president of Open Design Alliance. ODA is a technology consortium that provides complete interoperability solutions for CAD and BIM. We're also an official Building Smart partner. Our primary OpenBIM technology is our IFC SDK, which is a full-featured developer toolkit that allows high-quality IFC support to be integrated into any application on any platform. ODA IFC technology is being used by a wide range of major vendors, including Autodesk, Bentley Systems, Esri, and many others. Today, I'd like to share with you some of our recent advancements in OpenBIM, broken down into the following areas: core IFC technology, exchange with proprietary formats such as Revit and DWG, validation, and visualization. At the end, I'll also talk about some other interesting projects going on at ODA right now. One of our goals is to support the entire IFC feature set, and to do this, we've developed our own Express interpreter. The Express interpreter allows us to parse any version of IFC given the schema file for that version. It also includes sophisticated IFC constructs, including express functions, derived attributes, where rules, and global rules. Our Express interpreter makes IFC SDK the tool of choice for serious and sophisticated IFC users. In addition, we're looking to harmonize the implementation of our IFC SDK with our new STEP SDK, which I'll talk about a bit later. IFC and STEP are both Express-based formats, and we're developing a set of debugging tools which will improve the usability of the interpreter and support complex manipulations over schemas. In addition to the interpreter, we've written our own Express compiler that can generate C++ code for any Express schema. We use the compiler internally, not only for C++ code generation, but also for automatic documentation generation for our early bound IFC API, which is used by a number of ODA members. For established IFC schemas, we have a set of predefined classes generated by the Express compiler. But clients also have the option of immediately working with any new IFC schema using our Express interpreter and dynamic interface. You don't have to wait for a new ODA release. You can just download the most recent Express schema file from the BSI website, and you can start working with the new version directly using SDAI. Our generated code is 20% faster than this dynamic approach, so we provide both options for our clients. We offer source code licensing options as well, so clients are free to customize and adapt this advanced technology for their own needs. Basic editing of IFC models is a popular feature request from ODA members, including the ability to safely delete elements from a model and the ability to copy and paste elements within a model or across multiple models. Often a user will want to tweak a model slightly, and without the ability to edit the IFC directly, you have to go back to the original application that generated the IFC file, make changes to the source model, and regenerate the IFC. For minor changes, this can be an inefficient process. To address this issue, ODA is implementing basic editing support for IFC, including the ability to remove, clone, and create IFC elements. In this short demo, we select an element in a model and choose Clone, and the selected object is copied into a different model. The full subtree for the cloned element is included, and this functionality is currently available in beta and will be available for production use in June of this year. In addition to being included in our SDK, it will be available as a standard end-user feature in our Open IFC viewer. We've made significant improvements to visualization of IFC alignment elements for IFC 4.3 Release Candidate 4. We now support all new curve types required for vertical, horizontal, and cant alignments based on polynomial spirals and polynomial curves, as well as visualization of appropriate sweeps in accordance to railroad inclination. You can see some examples of these new curve types in this screenshot. Another interesting client request is for an automatic or semi-automatic method for populating property and quantity sets within an IFC model. To address this issue, we will be developing a new PSD QTO engine to facilitate the creation of property sets and quantity takeoffs from XML-based PSD QTO definitions. Finally, we can now read IFC JSON, which is a text-based encoding of IFC based on JSON, a common standard for transmitting data in web applications. ODA recently released standalone export from Revit to IFC. IFC Export is a feature of BIM-RV, our standalone toolkit for working with Revit files. Using BIM-RV, you can load a Revit file into any application, access the Revit data programmatically, and also visualize the model. With the addition of our IFC Export feature, you can now also export any Revit file to IFC. Using this technology, you can take a Revit file stored on a cloud server, for example, and convert it to IFC without any dependencies on the native Revit application. Our technology is cross-platform, so you can run this conversion on Windows, Linux, or Mac. Currently, we support full export from Revit to IFC 2x3, with IFC 4.0 support coming soon. A number of customization options are available, such as the ability to export only elements that are visible in Revit, or a set of elements selected by level or type. The export can optionally include IFC properties, common property sets, and quantities. Another common request from our customers is the ability to convert IFC Geometry to DWG, the native format of AutoCAD and a de facto industry exchange standard. Our latest IFC SDK can export the geometry from an IFC model to DWG. DWG is supported by a broad range of applications, so this provides an easy method for loading an IFC model into applications that don't support IFC directly. Here you can see an example of an IFC 4.2 model of a bridge that's been converted to DWG and then opened in a native DWG-based application. In addition, we can import DWG geometry into an IFC model. There's a strong industry need for tools to validate IFC models. ODA released a validation engine for IFC last year, and we made validation a standard feature in our free OpenIFC viewer. Our validation engine incorporates an early version of the new IDS standard from BSI. IDS, or Information Delivery Specification, defines the requirements for the exchange of BIM data. IDS is still under development by BSI, and we'll be updating our validation engine to use new versions of IDS as they're published by the IDS Working Group at Building Smart. In addition to IDS, ODA has also recently added support for mvdXML. A model view definition, or MVD, defines a subset of the IFC schema that is needed to satisfy one or more exchange requirements. MVDs are encoded in a format called mvdXML, and they define the allowable values at particular attributes of particular data types. mvdXML is often used to customize the export of IFC data. It's an older specification that was first published in 2013, but it's still in use today and is quite popular with some companies. ODA has implemented an initial version of mvdXML support that includes an API for reading, accessing, updating, and writing mvdXML data, and support for interpretable expressions. Currently, there are incompatibilities among various commercial implementations of mvdXML. ODA is working to provide a full implementation of mvdXML that supports sophisticated export of IFC data using a mechanism that can be standardized industry-wide. We'll be adapting our IFC export from Revit to use mvdXML later this year. OpenIFC Viewer is ODA's free viewer for IFC files. It's available for Windows and Mac, with a Linux version coming later this year. It's based on our IFC SDK and Visualize SDK, and it's proven to be quite popular with nearly 500 downloads per week. We've made a number of improvements to OpenIFC Viewer. The first is better visual fidelity. We use a technique called Screen Space Ambient Occlusion, or SSAO, to simulate the effects of ambient lighting in a scene. SSAO makes a scene look realistic by adding subtle shadows in the corners and around the edges of objects. We've improved our SSAO support significantly since last year, and you won't notice this difference dramatically if you open a file in our latest viewer, but the scene will look better, more realistic. Second improvement is more sophisticated inspection of collisions connected with our BCF support. You can see in this example, when you click on a collision, the offending objects are now displayed in blue and red against the rest of the model that has been faded and made transparent, so you can more accurately see the context of a collision. Another significant improvement is the addition of a plugin framework for the viewer. We often get requests from customers who want to customize the viewer in some manner. The new plugin framework provides a clean and modular interface for adding new features. We're using plugins now to implement the BCF manager and the validation component of the viewer. We have a new model statistics plugin available from the context menu by right-clicking on a model that shows instant counts by element type for the model. A new tree view plugin is a powerful tool for IFC model investigation. It allows navigation among a model in tree view form, and it's possible to open several trees simultaneously. Tree view is available from the context menu by right-clicking on any node in the Object Explorer tree that has an underlying IFC instance. I would encourage anyone who needs a customizable, professional-grade IFC viewer to check out openifcviewer.com. Full source code for the viewer is available to all ODA members. As a not-for-profit professional software development organization, ODA is the leader in toolkits for open standards. We're an industry partner that develops high-quality solutions for the long term. In addition to IFC, we now support STEP, the open standard for mechanical CAD. Both IFC and STEP SDKs are based on the same SDAI implementation by ODA, so data from both formats is available using the same ISO, SDAI, or C++ APIs. We released a beta version of our new STEP SDK in December of last year, and the current version already has enough functionality for creation of any desirable STEP model, including AP203, AP214, AP238, and the latest AP242. By the end of this year, we'll have full production support for STEP, including data access, editing support, geometry visualization, and the ability to do combined visualization of STEP and IFC models. STEP and IFC can also be combined with other ODA-supported formats, including DWG, Revit, Navisworks, and DGN. Clash detection can be done on the combined model, and you can also export the combined model to 2D or 3D PDF or to Navisworks. LandXML is an open standard used for the exchange of civil and survey data, including points, alignments, roadways, parcels, and more. We've recently started work on a new LandXML SDK, and we'll be releasing a beta version in June that supports read and write access. By the end of this year, we'll have a full production release for LandXML that includes visualization support. In January of this year, ODA started work on a new Scan-to-BIM project. Scan-to-BIM is the process of taking point cloud data generated by laser scanners and converting that data into IFC or Revit BIM models. Laser scanning is a standard technology today, used for renovation projects and new construction. Scanning technology has advanced rapidly, but our ability to efficiently work with the point cloud data generated by modern scanners hasn't kept up with the latest scanning advancements. There are a lot of Scan-to-BIM services available today, but they tend to be expensive and they require a significant amount of manual effort to achieve a result. ODA would like to democratize Scan-to-BIM. We're developing a toolkit that will convert point cloud data to IFC or Revit, with the goal being a fully automated process, or as close to that as possible. The project is being funded by a group of major industry vendors, and the result of the work will be made available to the broader industry. Our Scan-to-BIM SDK will be economical and accessible. Our vision is that Scan-to-BIM should be a standard technology that can be integrated into any application on any platform. If an iPad generates a point cloud from a scan, our technology will allow that point cloud to be converted to a BIM model in real time, opening up a lot of new possibilities for application developers. The project is currently funded by a dozen industry vendors, and we're seeking additional partners. It's an interesting and challenging project from a technology point of view, And it's also a valuable and much-needed service for the broader industry. If you're interested in Scan-to-BIM, please join us. You can find out more about our Scan-to-BIM project at opendesign.com. Thank you for your attention, and I'd like to thank Building Smart for the opportunity to speak with you and to share our message. If you'd like to discuss any of the topics I've talked about today, feel free to contact me at president@opendesign.com.